Good day to all. Today we are going to see about the braking of three-phase induction motor. See, the braking is the process of reducing the speed of an induction motor. In braking, the motor works as a generator which developing a negative torque which opposes the motion of the motor. The braking of an induction motor is mainly classified into some types. There are regenerative braking, plugging or reversing voltage braking, dynamic braking, AC dynamic braking, and self-dynamic braking, then DC dynamic braking, then zero sequence braking. See, first one is the regenerative braking. The input power of an induction motor is given by the formula which is P in sense input. P in equal to 3 VI AS cos by S, where pi S is the phase angle between the stator phase voltage and the stator phase current is nothing but the IS here. For motoring operation, the phase angle is always less than 90 degree. If the rotor speed becomes greater than the synchronous speed, then the relative speed between the rotor conductor and the air gap rotating field gets reversed. Then this reverses the rotor induced EMF and the rotor current component of the stator current, which balances the rotor armature turns. When the pi s is greater than the 90 degree, then the power flow to reverse and gives a regenerative braking. The magnetizing current produces the air gap flux also. See, the nature of the speed torque curve, when the supply frequency is fixed, the regenerative braking is possible only speeds is greater than the synchronous speeds. Then only the regenerative braking is possible, when the speed is greater than the synchronous speed. With variable frequency speed, it cannot be obtained for a speed below synchronous speed. The main advantage of this regenerative braking is that to generate power is fully used, and the main drawback is that when fed from constant frequency source, the motor cannot employ a below synchronous speed. This is the disadvantage of this regenerating brake. See, if you see the graph, it is versus speed versus torque. Let's see, the motoring is get downwards, then the regenerative grade will be upward. So if it is a regenerative braking will be more, then automatically motor will going to brake downwards. Then plugging. Plugging is nothing but a speed end phase the sequence of supply of the motor running is reversed by interchanging the connection of two phases of the stator on the supply terminal. See, operation changes from motoring to plugging. We'll see. And plugging is the extension of motoring characteristics for a negative phase sequence from a third quadrant to second quadrant. The reversal of phase sequence, the reverse direction of a rotating field also. So you can see over here, this is the first quadrant and this is the second quadrant, this is the third quadrant. Okay. If the motor applying over here, then the plugging will from the second quadrant to third quadrant. You will see the graph also, it's the same like that, speed versus the torque. Then the dynamic braking. See, AC dynamic braking. The dynamic braking is applied when the motor is run on a single phase supply by disconnecting the one phase from the source and either leaving it open or connecting with another phase. The two connections are respectively known as 2 or 3 lead connection. When connected to an one phase supply, the motor can be considered as to fed by the positive and negative sequence. Three-phase set of voltage. The total torque produced by the machines is the sum of torque due to positive and negative sequence. So, when the rotor has high resistance, then the net torque is negative and the braking operation is uptime. So, assume the phase A of star connected, then the motor is open circuited. See, if it is this phase A of the star connector motor is open circuited, then the current flow through the phase A becomes 0, which is here IA equal to 0, and the current through the other phases IB equal to minus IC. Then the positive and negative sequence component IB and IN are represented by the equation IB equal to 1 by 3 into IA bar plus alpha IB bar plus alpha square IC bar, which is equal to 1 by 3 alpha plus alpha I bar B minus alpha squared I bar B, which is equal to J I bar B divided by root 3. Then it will becomes IB equal to 1 by B IA bar plus alpha squared IB bar plus alpha I bar C equal to 1 by root 3 theta plus alpha I bar B minus alpha squared I bar B, which is equal to minus J I bar B divided by root 3, where alpha is equal to e to the power of j into 20 degree. This is the equation. Now we will see the diagram for this self-exciting braking capacitor. You can see over here there is a power supply, then which is connected to the push button switch, then it will connected via capacitor with that motor. When we are applying the brake, it will get reversed. See the graph, the A curve will become like this, then the B curve. If it is meet with each other, then the C curve will also come. Then if it is get reversed, you will see this graph also for speed versus torque. And the DC dynamic braking. See, in this method, the stator of induction is connected across the DC supply. The method for getting a DC supply with the help of a diode bridge, then the direct current flow through the stator produces stationary magnetic field, and the motion of the rotor in the field produces the induced voltage in the stationary winding. The machines therefore works as a generator, and the generator energy is dissipated in the rotor circuit resistance. That's it's giving the dynamic braking. You will see over here, this is the three lead connections with the DC dynamic braking. These are connected with that series with that power supply. This also the zero braking. We will get that. As we know, there are three types of braking, which is regenerative dynamic and plugging and braking. But for synchronous motors, only dynamic braking can be applied through the plugging can be applied theoretically. Thus, the regenerative braking cannot be applied to them as they need higher than the synchronous speed. Dynamic braking is done by disconnecting the motor from the connecting it across the three-phase resistor. That's all. Thank you.